1-1, Part A for College Algebra. All right, so the required skills on here is, I put on there, is the point on the graph when given an equation, complete the table when given the equation, sketch the graph, linear and quadratic, and then identify the x and y intercepts for any graph. All right, so the first example says, determine whether the point -4, -10 is on the graph of the equation. Now, yes, I get it. You could go ahead and type this in and graph it and then go see if you can find that point. But algebraically is a good way to handle this, which simply we're going to plug in. We're going to keep our y equals right now, and we're going to plug in that x value of -4 into the equation and see if it indeed equals -10. So here, -4 squared is a positive 16. 4 times -4 is a minus 16. So then 16 minus 16 would be 0, minus 10, minus 10. So as you can see up here, then yes, this point is on the graph. So again, I just finished the sentence, but yes, this point is on the graph of this equation. And that is how we determine it quickly, algebraically. That's not requiring you to guess and check or try to do things. Even though, yes, you can use the graphing calculator, but on a test, if we're asking you to show algebraically, if this is the case, this is how you would do it. Okay, so then here's another one, because why not? Determine whether the point 312 is on the graph. So we have the same one. So again, I'm going to plug in everywhere I see an x, I'm going to put a 3. And then I use the same equation because I knew it would be fine. So here we've got 9, 3 squared, plus 12, minus 10. 9 plus 12 is 21, minus 10, and you get 11. So it is close, but that means that point is not, so no. So the answer would be no, this point is not on the graph of the equation. So again, this is how you can truly prove it, other than saying, I looked at the graph and it didn't look like it was on it, or stuff like that, right? Like this is the algebraic prove it, which is what you'd be required to do on an assessment. So then now, and I just went with a linear one to start out with, complete the table for the following equation. So they're going to give you a table on your assignment, but I need to make a table real quickly. So I have my x column. So I am going to pick the points -1, 0, 1, 2. And then what I'm doing in this next column is the equation. So -3 times -1 plus 4, -3 times 0 plus 4, -3 times 1 plus 4, -3 times 2 plus 4. So now I'm going to do my math to determine my y values. Well, this then equals 7. This equals 1. This that equals 4. Sorry. This one equals 1. I was jumping ahead. And then this equals -2. So then if they ask you for the actual x, y point, you would write -1, 7, 0, 4, 1, 1, and 2, -2. So there's that. Now, they may ask you to graph it. Okay, so I'm going to go and graph those points. So I had -1, +7, which is this point right here. And then I had 0, +4. And then I had 1, +1. And then I had 2, -2. And so then, as expected, I did not make it through that line. And I have a linear equation and a graph of such. All right, so another, complete the table for the following equation, and they give you equation. Now, my hint on this one is solve for y first. I think that will make your life easier if you actually do that as your first step. So when I do that, I end up with y equals x squared plus 6x plus 2. Okay? And now we're going to put this in a table. So I like to, if I'm doing a quadratic like this, I really like to do the x equals -b over 2a as to know what my vertex is. So for this problem, that means negative 6 over 2 times 1, which is x equals negative 3. That gives me my middle term, or my vertex, and then I can have negative 2, negative 1, and I can do negative 4, negative 5, so I'm picking points around it. And of course, you can write it the other way. I don't know why I wrote it that way this time. And so then here you are literally plugging in those values to the equation to determine what your y value is. And so I will do that. Negative 2 squared plus 6 times negative 2 plus 2. Negative 3 squared plus 6 times negative 3 plus 2. Negative 4 squared plus 6 times negative 4 plus 2. And negative 5 squared plus 6 times negative 5 plus 2. So then you are doing the math. And when you do that, this gives you 1 minus 6 plus 2, which is negative 3. This gives you 4, I'm like looking and thinking, this gives you 4 minus 12 plus 2, which is a negative 6. Negative 7, negative 6, negative 3. And if you do it really pretty, that's what happens. And so for your x, y, because I know in the assignment they do this as well, you're just making sure you're putting it in order. And we'll graph it on the next slide, just to make sure your graphing quadratic skills are great. So when I graph these, negative 1 was at negative 3, negative 2 was at negative 6, negative 3 was at negative 7, and then we started going back up. And I get it, mine may not be perfect, so do the best you can when you're drawing without a grid. And there's the graph. It is a quadratic, so it's a parabola, has that U-ish shape to it. Now we need to identify the x and y intercepts. So x-intercept is the point where a line or graph, in that sense, crosses the x-axis. And at this point, the y-coordinate is always 0. And then the y-intercept is the point where a line crosses the y-axis, which is at this point, the x-coordinate is always 0. All right, so you have a graph here, and they're asking you for the x and y intercepts. So the x-intercepts, and there is multiple on this graph, is at negative 7, comma 0. That's that one right there. Negative 2, comma 0. That's that one right there. And 4, comma 0. That's that one right there. And then the y-intercepts, or there's just one, y-intercept. The y-intercept is at 0, comma negative 4. So that's why we talked about where the zeros were on the intercepts. And that is it.